Imports, which is a GHC extension that we have been working on, myself, Rodrigo and Adam, for about the last 6 months. And this extension has gone through the whole process. The conception process, the thought process, the GHC proposal process, the paper writing process, the implementation process, and now we finally reached the finale, the Haskell Implementers Workshop. I do know from yesterday, I'm actually quite pleased, I can now stroll this way and this way, but I also have a strolling direction down here as well to meet people like this as well. So I thank the organisers for thinking about my strolling capacity. What problem are we attempting to solve? So we've actually heard quite a lot about Template Haskell already in this ecosystem workshop, and this is a very common example of how you might use Template Haskell in your programs. In this example, we have a data type T, and we want to derive lenses for the data type T. Well, how would you do that? One very common way is to use a declaration splice, which instructs the which you call this make lenses function, which is provided by the Template Haskell library, to make lenses for your data type T. And then when the module is compiled, this splice will be executed, and the definitions for the lenses will be inserted right there into the program. So what is the problem with this program? Well, I am just using a very small part of my dependency tree in this top-level splice. So I only really need the code for make lenses to be available at compile time. But at the moment, the compiler doesn't know anything about that. So explicit level imports is about specifying clearly to the compiler what do we need at compile time and what do we need at runtime. And once the compiler is able to know information, in the future, we can use that information in our build systems to supply more precise builds. So yes, when the make lenses function might just import a single module, but really this precision has much greater ramifications because I only imported the application module in the place where I use a splice. The application depends on the library, the parser, the runtime, money, receipt, shopping, so on and so on. And if I require this module compile time, this module compile time, this module compile time, all the way through my dependency structure. So at the moment, if you are not able to be precise about what is needed when, then very quickly you just require everything at both stages. Okay, so at the moment, firstly, we need to reflect on how the compiler determines what is needed when. And that is determined using a level system. And level systems are common in multi-stage programming languages, and the level system ensures that things that need a compile time are executed at compile time, and things that need a runtime are executed at runtime. So what the compiler will do when it's looking at this module is it will assign a level to all the uses of variables in this module. When you go inside a splice, the level decreases by 1, and when you go inside a quote, the level increases by 1. So to perform this analysis, we can see the use of make lenses is inside a splice, so that level is going to be -1. And the usage of T is defined at level 0, which is the top level. Make T is level 0, that's top level. Foo is level 0 because that's top level. S is level 0 because that's the top level. And T is used at level 0 because we subtract 1 to get inside the splice and then add 1 to get into the quotation. So now the compiler has done this analysis that says, okay, well, make lens is used at level -1. It needs to check that it's going to be available at level -1, which and level -1 can be thought of as being the same as compile time. So it's this principle of levels which brings order to the difference between compile time and runtime. Do people know about levels already, or is that kind of a programming language theoretician concept which I've just dumped on everyone? A lot of blank looks here. Okay. So levels are the concept the type checker uses to enforce order, but it uses levels in order to ensure that evaluation is going to be well staged. So there are 2 stages that in particular we care about, as I've said already a lot of times, compile time and runtime. And the type checker uses the rules in the type checker to assign levels to things, and then once the type checker is confident that all the levels lined up, that means that when the program is executed, the parts which should execute at compile time, and the parts which should execute at runtime execute at runtime. So this distinction between levels and stages is perhaps one which is, appears quite technical, but it does allow you to keep your thinking in order for when thinking about these things. Right, so levels are a semantic thing, and stages are an operational thing. Levels ensure we can run in a staged manner. So just to drill in the principles of levels a bit more if people aren't familiar, which, to be honest, if you came to this talk, you might have expected I would talk about levels at least once, but maybe not 5 times, but we're going to go through it again. But X here is bound at level 0 because it's the top level. X is used inside the quotation at level 1 because we go inside the quote, and that increases the level by 1. In this example, X is bound at level 1 because it's bound inside the quotation, but used at level 0 because it's used inside the splice. In this example, X is bound at level 1, but used at level 1 as well because we go inside the splice and then inside the quote, so it fixes level. The principle of level states, a variable can only be used at the level it is bound. And that is the key principle which ensures that the level system will ensure a well-staged execution in the end. Because if we consider what this second example means, well, it means, so we're quoting a program, so this program is going to run at some point in the future, but that program in the future is going to bind a variable X. But in order to construct that program, I want to insert what the value of X is going to be in the future right now. So the causality is mixed up somehow because we can't possibly know what X is until potentially indefinitely into the future. So the basic principle level states a variable can only be used at the level it's bound. Any questions about levels before we?
The first 2 are wrong, right?
Yeah, so they're rejected programs, yeah.
And the third one's okay?
Third one's okay because of the principle of levels.
And then you get the width constraint for who?
The basic principle of levels, if we don't talk about the compiler doing additional things, is you must use a variable at the level it's bound. Right. However, as Vlad points out, you can introduce additional rules, which we'll get onto at a later point. Right, so again, you can perform this level annotation game on any example. I think this is more of a puzzle than a pub quiz, as Andrew would point out. The rules of levels are quite well defined, and you can spend many an hour annotating your own programs with 1s and 0s if you wish. But the principle of levels hasn't really yet got into imports. At what level does this import bring things into scope? Well, that is actually a slightly confusing question because I've annotated this power program now, and if you look, I've used the subtraction at level 0, but I've used multiplication at level 1. And GHC will accept this program today. So how do we reconcile this with the principle of levels? Well, at the moment, if you import something, it just brings it into scope at all levels. Oh, nice and simple, but as we'll see, that has some quite significant downsides. So at the moment, we have, local variables brought into scope at a particular level, imports bringing things into scope at all levels. And this special rule is one which Vlad was talking about earlier, is known as cross-stage persistence. We add this special rule which says if something's imported, we can use it at any level. Currently. What is the problem with that rule? So if I have compiling my module for the compile time stage, which is indicated by this C here, then because this rule exists which says I can use any imported identifier at any level, then what that places dependencies on what I need at particular stages. So in particular here, because I import prelude at level 0, and this is being compiled for compile time, I need the module for compile time as well. That's the first dependency. But also, because I import it at level 1, and I use these things inside a quotation, I also need prelude for runtime as well. So, and it's even worse than that, because we perform this analysis of the usages of Prelude, but the compiler doesn't do that. The compiler just says, if you import anything, you must need it at every single stage. You must need everything at compile time and everything at runtime. So very quickly, everything collapses together, and you can't really separate properly what is needed at compile time and what is needed at runtime. So if only the language had a mechanism which allowed you to explicitly say in your import what level something was going to be made available at. And that is the purpose of the explicit level imports proposal. So the first part of explicit level imports is to disable this rule which says that an import brings something into scope at all levels. And that rule is that language extension is called no implicit stage persistence. And all that does is it says, well, rather than bringing things in scope at levels -1, 0, and 1, an import just brings things into scope at level 0. Nice and simple. So now, if I compile this module for a runtime, because we only import things at level 0, we only place a dependency on the application of runtime and control.lens at runtime. However, Duncan will point out that this program is now incorrect because we use make lenses at level -1 here, but we only bring it into scope at level 0. So now we've brought order to our dependencies and restricted the rules about what levels imports bring things into scope, we can add special syntax, which allows you to add more expression again in a more controlled way. So now there are splice imports and quote imports. Splice imports bring things into scope at level -1, so you can use them in splices in the -1 context. Quotes bring things into scope at level 1, so you can use them in the quotation context. So now I've rewritten the program, so I say import control.lens at the splice level, and my little arrows now point to the correct dependencies. Application is required at level 0. Control.lens is required at -1. So now we don't have all these additional dependencies based on this very, very permissive cross-stage persistence rule, as it's known in the literature. Leonard.
Sounds like you only have -1, 0, and 1.
Yes. Yes. So,
you need 2.
Well, yes. So with the current proposal, you only are allowed to use -1, 0, and 1, and you could extend the system to have a explicit number. However, we attempted to do the simplest thing possible to get it through the proposals process. And if this is an accepted idea, then it will be very easy to motivate that extension.
Just repeat the keyword.
Yeah. So for the camera, the suggestion was just to repeat the keyword a lot of times.
But if you did allow other levels, that wouldn't actually have any operational effect on like what a build system would have to do, would it? To actually compile the dependencies of a module. Because you need to compile a particular dependency for the build machine or for the host machine, and whether it's a stage -1 or -2,
right?
Doesn't
in
really
this, so Ben is asking like, okay, there's only 2 stages, so what is the point of 2? Like, if you go 2, 3, 4, 5, then you're not going to go have additional, like, there's no more stages to add on to. If you do cross-compilation, you need 3 stages.
Okay, fair.
Yeah. So there are more complicated stage structures that you can have. This work is only concerned with levels, and the stage part is implementation specific, and can be modified in future. Yes.
Why do you need explicit annotations instead of letting the compiler infer the annotation?
Good question. So the question is why do you explicitly annotate the import rather than letting the compiler work it out? Well, firstly, Haskell programmers are already very happy to write type signatures for a lot of things which indicate the compiler what your intent is. So I believe it is Haskell-like to be explicit about levels as well. And the second implementation reason is that at the moment GHG can work out all the dependencies of a module based on the import header. So that maintains this property. that you can just work out what you need by looking at the import header, rather than analyzing the body as well. Question, Dylan?
Well, I suppose then Leonard's question, but I'm just making sure. I was wondering why do you have to need both language extensions? Couldn't explicit level imports imply no implicit stage persistence? But clearly, if, you still need to import things for stage -2 or whatever, then you would not turn on no implicit stage persistence. You just do a bland import, and that way it would be available at -2. Is that how you get things?
Yeah, well, okay, honestly, no one's using like -2, +2. It's very, very theoretical. Yes, yeah, okay. You know, if you like, most Template Haskell users writing programs like this, we wanted to nail like this particular case. First, just my opinion. The other question is, why do you have 2 language extensions? And the reason is it factors very nicely having these 2 extensions. One, it controls this already existing behavior. So in GHC, implicit stage persistence is enabled by default because that is the existing behavior. We're just giving it a name and allowing users to control it. And you can imagine in future you might have a different mechanism for bringing things into scope at different levels. So that's why explicit level imports is separate, because one allows you to bring things into scope in one way, one allows it in another way. So,
can that extension imply reformer?
I think it does. I think it does.
Okay.
I think it does, says Adam and Rodrigo. that detail has been lost to my brain, I think, actually. That's it. Rodrigo?
Enable implicit stage persistence and explicit level import, so you can start bringing the syntactic feature into your code base while not breaking everything else.
Yeah, but there's not that much point in doing that because Rodrigo says you can enable them both at the same implicit stage persistence and explicit level imports at the same time, so you can use the syntax, but without having the type checker check exactly what you're doing. Yes.
But if you use a splice within a splice, it's -2, right?
If you use a splice within a splice, that's -2. Yeah.
By making a separate module.
Yes. So if you're doing splice within a right. The question is about splice within a splice or the -2 context. So one workaround you can use is you can have 2 modules. That would get you to the -2 level. You have one splice in one module, which imports an identifier, and then using a splice in the other module. That works out if you need a workaround. So that's fine for nested splices, which I've never seen anyone else write apart from me. And for nested quotation, GHC doesn't allow you to write nested quotations. So you can't actually get to the +2 context, given the current implementation restrictions. Yeah. Okay. So yeah, any more questions? I'm happy to always take those. Well, I'll carry on for now. Right. So likewise, we have the quotes, which allows you to offset the imports the other way. So in this example, now I am able to precisely say I need prelude at level 0 and I need it at level 1, which allows this program to type check. And that means I have a dependency on prelude at compile time and a dependency on prelude at runtime. Okay. Right. So to summarize, the first phase of the first idea was to restrict this implicit stage persistence property of imports, which meant that we placed less restrictions on dependencies, but then this was too restrictive to actually write programs, so we had to introduce syntax in order to allow programmers to express these dependencies, but in a more precise manner. Okay, so the case I implemented, this extension is implemented, it is merged, it is going to be available to be used in 9.14. And so I tried it out on Pandoc. And what my goal was here is I wanted, so one benefit of this, which I've not really got into too much, is a lot of libraries will import Template Haskell stuff from external packages and only use it in top-level splices. But at the moment, GHC must pessimistically assume that you need all of your own library for compiled time evaluation as well. And Pandoc is an example of this. It has 200 modules, and one module right at the top of the dependency tree has a top-level splice. So that means everything else in the pandoc library has to be compiled to bytecode when you load it into GHCI. On the off chance that the user uses this one of the modules in the top-level splice. So I modified pandoc to use explicit level imports, and now the no-code compile time is halved because it doesn't do all this unnecessary work of compiling all the modules to bytecode. So that was just very, very easy win. I modified 5 modules, added 5 splice import statements, and it makes a big difference in certain workloads. Okay, so yeah, since I last gave this talk, the implementation, that was actually a bit of an ordeal, to be honest, but it is now done. But we still have these 3 pieces of future work to be done. So this kind of, now we have this this more explicit way to model dependencies in Template Haskell. It does make cross-compilation potentially easier in future. That is hypothetical, but the ability to be precise about what is exactly needed when does allow you to think more clearly about what is needed in cross-compilation scenarios. We want to allow level correct package dependencies in Cabal, for example. So you need say I need this package at compile time, this at runtime, just to keep that separation. Oh yes, I've also fixed it with Template Haskell as well. Okay, right. That's okay. So that's the talk. I've hit the time limit today.
Yes, exactly.
Exactly. Oh, that was good.
There's still a bit of time for questions.
So a little bit of time for questions, and then I'll move on to the next talk. Right. Yes, Travis.
What's the practical impact of implementing level correct package dependencies? Like, why does Cabal care? What does that buy you?
Well, at the moment, Cabal is very pessimistic as well about compiling all your package dependencies for every possible scenario that you might need. So if you type Cabal build, you'll build all your dependencies in static way, dynamic way, sometimes profiled way, profile dynamic way, which does add up quite a lot. And also in some situations, and like cross-compilation situations, there's a significant number of packages which don't build on certain targets, like WASM, like JavaScript, for example. It could be a way of just allowing you to have that precision to say, well, these are the things I'm going to cross-compile, but I can use more complicated things at the meta level if I want to.
Can you imagine Cabal being smart enough to say, okay, I only need bytecode for this package because it's only used at compile time? So
Yeah, I think that's kind of the longer term vision. Yeah. Yes.
Does it work with import qualified post?
Well, a great question. So, does it work with import qualified post? Well, I personally find these discussions just a bit boring. That's my right. I don't care at all. So I let other people decide that. And you can write splice before and after, but you can only write quote before. No, you can write quote before and after as well. I feel like that would be a suitable compromise. You can write splice before and after, but you can only write quote before. That would be and another extension, the genius of a committee. So,
If there are more questions, then probably better to ask later.
Yeah, go.
The
Yeah.
next speaker, Alice couldn't be here, so the next speaker for intentional. Let's take a round of applause.